Hi viewers, this is Dr. Jana and you are watching video with me on this algorithms, searching algorithm. Searching and sorting algorithm are the two important algorithm, and in this video we will be covering the searching algorithm. See, searching algorithm here refers to the finding an item in the array that meets some specified criteria. When some criteria is met, based on that we can find some item, right? Then the searching algorithms are designed to check for an element or retrieve an element from any data structure. Either we check one element or retrieve an element from this data structure. That is the purpose of the searching algorithm. We have a different type of searching algorithm. The first algorithm is the linear search. So it is a sequential search. Linear, as you understand, first we go for first, second, third, like that. It is a sequential search, one by one. So sequence search a, I, x, n, we will take these things, and I is equal to 0, if I greater than n, then print element not found, or if a of I is equal to x, then print element is found. This is the things. This is the algorithm, is very simple algorithm. So now I is the temporary pointer and x is the search element and n is the size. So these are the things we have declared. Let us take an example. From this example we can understand. Suppose we have the data sets 5, 9, 12, 10, 25. So these are the indexing, like 0 index is 5, 1 index is 1, 9, 2 index, like that it is there. Now I am going to search whether x is equal to 12 is there or not. Then how do we go for this linear search? First we find a is just like the, you see, an array, and array is 0 indexed, you know. A of 0 is equal to 5. You see the 0 indexed here, 0 it is 5, a of 0 is equal to 5. So this is not equal to 12. Simple. Then I plus, then you go for the increment. Then a of 1, what is a of 1? A of 1 which is equal to 9. So this is also not equal to 12. Then you go for increment. Then a of 2 is equal to 12. So print element is found. So this is the very simple algorithm, we can find it. Then we are having different type of searching, as one the linear search, another the binary search. This binary search, it assumes that we are given an array of records that is sorted. That array of record is given and it is also sorted already. For instance, an array of records with integer keys sorted from smallest to largest, okay, in increasing order, okay, smallest to largest. That is, say for example, some ID numbers, or an array of records with string keys sorted in alphabetical, say A to Z, like that, okay, the names, etc. So it is already given, suppose. Then in the binary search pseudocode we put it like if size equal to 0, found false, else. So middle is equal to index of the approximate midpoint of array segments. If target which equal to the middle, then target has been found, else. So this is the simple technique we are using. Now come, let us, when I explain you practically, then we will have an example. Suppose you have an array and the 0 index 0 is a of 0 is equal to 3, a of 1 is equal to 6. You can see here clearly a of 0 is equal to 6, a is the array, and a of 2 is equal to 7, a of 3 is equal to 11, a of 4 is equal to 32, and a of 5 is equal to 33, and a of 6 is equal to 53. Fine. So now we are going to find whether 7 is present or not. So target is 7, x is equal to 7, remember. So now what you do, we find approximately the midpoint in this binary search. I am talking about the binary search, okay. There what we are doing, yes, so it is a linear search, sequential search, one by one we are going. In the binary search we are trying to find the middle value. So you see the middle value, there are 3 plus 3 6, 7 plus 7 elements are there. So middle value, of course it is the a of 3 is the middle value, okay. Then find approach the midpoint. So once you find what is the key value here, it is 11. So is 7 midpoint key? Whatever things where the target is 7, is this is the key? No, it is not the key. Then what you need to do? Then because it is already sorted, so when it is sorted, then which part you have to take? So 7 is less than 11 or greater than 11? 7 is less than 11. So in that case, the left hand side 3 we are going to take it. Out of that, which is the middle? So I am going for this middle, okay. Then what we do? 3 6 7 3 we are taking. Then what is the midpoint here? I am taking 6 is the midpoint. Now is 6, you see, the next question is that is 6 is the target key of the midpoint? No, it is not the things. Then what do we do? You see, is the target less than the key? Is 7 less than 6? No, 7 is not less than 6. Then next one, is 7 greater than, if the target is greater than midpoint? Yes, it is there, okay. So like that So then what we do, then search for the target in the area after midpoint. So here, because only one option is there for you to search 7, that is the A of 2. So A of 2 is the target. Okay, you got it now. So now find approximate midpoints, it is there. So now is target midpoint key? Yes, it is there. So now you got it now. Now how to go for the binary search implementations? So the same thing, just we writing an algorithm and writing the coding here. I think you can clearly understand. Size underscore t the middle. If size is equal to 0, found false, else. So like that you go on for these things. What I explained, the same algorithm we are going to do. Now the relation to binary search tree. So that I told you that binary, and when you go for the binary search tree, how to do that? So this is the array is given. A of 0 is equal to 3, A of 1 is equal to 6, like that all these key values given there, 3, 6, 7, 11, 32, 33 and 53. Now if I go for a binary search tree, what is the principle of the binary search tree? Binary search tree, we put it like this. Suppose I have taken the root is equal to 11 here, the midpoint something like 11, then what are the values left to the key value 11? They will be to the left of this root. Okay, and whatever the key value more than 11, they will be to the right. This is the right subtree and this is the left subtree. Okay, so 11 has 2 child, that is 6 and 33, and 6 has 2 child 3 and 7. You see 6 is less than 11 and 3 is also less than 6, and 7 is greater than 6, but it is also less than 11. Like that we have just made a search tree. It's clear. Now we start at the root. Okay, what is the root here? Just we are taking the midpoint 11. So in the root in the middle, so then is it 11, is 11 equal to 7? It is not that. Then 7 is less than 11, then we have go to the the left root. Okay, sorry, left subtree. In the left subtree, what is the parent here? It is 6. Is 6 equivalent to 7? No. Then can we go to the left hand side? We cannot go, because we have to, because 7 is greater than 6. So in that case we have only the option, so visit root subtree, then we go for the thing, then we go for the 7 and it is found. Okay, then in the binary search tree analysis, so what are the analysis we do? Worst case complexity we go for that, and what is the maximum depth of recursive calls in binary search tree as a function of n. Then each level in the recursion, we split the array in half, divide by 2. Therefore maximum recursion depth is that is floor of log n base 2, right? Worst case is order of log n base 2 also, right? So this is the thing. So you know what is the floor and what is the ceiling value already you know. If you do not know, just I am giving an example. Suppose there are 5 number of keys. Okay, then what will the middle? So 5 divided by it is 2.5. 2.5 cannot be, it will be either 2 or it will be 3, right? So in that case what we do, if you go for the flooring, then 2.5 will be equivalent to 2. If you go for ceiling, 2.5 will be equivalent to 3. That is the thing. So average case is also, it is order of log n base 2. Okay, these are things. Then can you do better than order of log n 2? Average and worst cases of that serial search is order of n, and average and worst case of binary search is order of log n base 2. And can we do better than? Yes, you can, using a hash table we can do better than that one. Okay, so then we'll use this hash table, and because it is related, so let us understand what is this hash table and how it is important. The simplest kind of hash table, it is an array of records. It is just like you see, this example has say suppose 701 of records. Why? Because it is starting from 0, so the last one is 700, so it is 701 number of records are there, right? So then what you need to do, then suppose this index A of 4 or whatever it is there, this number is something like that 5066435548, like that it is there. Or and this you can see the number might be a person's identification number, and the rest of the records has information about the person. Okay, so this number what you are using, that is just the personal identification number, and the remaining is photo and other data will be there, right? So this is the things, this is the concept about this hash. Okay, like that there are some persons, their identification number will be there, say, and all these details will be there. When a hash table is in use, some spots contain valid records and other spots are empty. Okay, so you see this A of 0, there is no record, and A of 3 there is no record, and A of 1, A of 2, A of 4 they are containing valid records, right? Then what you do, in order to insert a new record, the key must somehow be converted to an array index. First thing, it will be converted to array index. So what is that thing? Say for example a of 0, a of 1, like that, and the index is called the hash value. Whatever the index we are calling, this is you are calling the hash value of the key. Okay, that you try to understand. Then what you do, then typically we create a hash value, that is because what is the maximum number of things, it is 0 to 7 is 701. So we do number mod 70n. That means whatever things after 701 it will come. So it is this mod 70n 1. So it will come 0, 1, 2, like that. If it is 0, it will come in this group here. If it is 1, it will come here. It will come like that. Then suppose I take an example. Are you following me? Suppose the personal index number of a person 580 something like this, 685 something like that. So 685 whenever this modulus 701. So after division some remainder will be there. What is that remainder? Where it is fitting, that will be the index value for that one, right? So now say 701, it is coming 3. It is coming 3. How do you come to know it is coming 3? So divide it by 701. What is the remainder? Remainder is coming 3. So that means how do you fill up that one? So now index array of index 3. The a of 0 is equal to 0 something here, a of 1, a of 2. So this number will be allocated to that one. You get it now? So this is the concept of indexing. The new record is inserted there. Similarly, suppose I want to put something like that, a number, personal index number 701 something like that. When I go for this modulo 701, it is coming 2. So here is another new record to insert, which has a hash value, but it has a collision. See, you get it now? It has a collision because in 2 Abraham Lincoln or something like that, President of America, some photo looks like that. I do not know who is the person. So it is already existing. Okay. So then what you need to do? This is called a collision because there is already another valid record at 2. When a collision occurs, move forward until you find an empty spot. Then what will do? Then a of 3 it is already there. A of 4 is there. When a of 5 it is empty, then you put it at a of empty. Okay, you get it now? So this value will be put to a of empty. So this is the procedure you follow, right? Then how do you search for a key? Suppose a personal index number it is given something like that 70. You can see it in the right 7014 something it is given. Then the data that's attached to a key can be found fairly quickly. How do you do that one? So then when you are going for this modulo 701, it is coming 2. So 2 a of 2 it is coming. This is, so suppose saying this is not me. Then what do you do? Then 3 it will check. Then 4 it will check. Then 5 it will check, and like that it is coming yes. Okay. So my hash value is 2, but this is the person is identified. You get it now? So now number is this and my hash value is 2. When the item is found, the information can be copied to the necessary location. Okay. All right. Now suppose I want to, yeah, you got it now? Now suppose I want to delete a record. Suppose the a of 4 you want, please delete me. Okay. So you want to delete me, what will do? So now record may also be deleted from a hash table, but the location must not be left as an ordinary empty spot, since that could interfere with the searches, right? So this is the thing. So then deleting a records may also be deleted from a hash table, but the location must not be left as an ordinary empty spot, as I told you, since that could interfere with the searches. Now the location must be marked in some special way, so that search can tell that the spot used to have something in it. Okay, like that. You can see the a of 4, just it is marked like this, right? So then we go for the hashing. Hash table store a collection of records with keys, and the location of a record depends on the hash value of the records keys. And opening address hashing and all these things you can do it here. Open address hashing, then we can go for some clustering, then double hashing, chained hashing, like that you can go. And you go for the time analysis of hashing. The worst cases it is order of n search, luckily average case is more promising. Then we use to define a fraction called the hash table load factor, that is alpha, that is number of occupied table locations by the size of the tables array. So from this we can get alpha, and average search time, it is equal to half of 1 plus 1 by 1 minus alpha. So but in case of portable hashing, it is logarithm of 1 minus alpha divided by alpha, and chain hashing, it is 1 plus alpha by 2. Anyway, so these are things you study in details when you go for this hashing. So I hope you have understood the minimum concept about the sorting algorithm, and to some extent what is the hashing it is taking place, hash table takes place. So thank you for watching this video. If you like this video, please share with your friends, and also don't forget to subscribe this channel also. So please take care of your health. Bye bye.